So the first thing that we're going to talk about for the rest of this unit is chemical reactions. And to some of you, this might be old information. You may know all of this already. For others of you, you may have been exposed to it, but there may be some new things that I mentioned that you may not have heard of before. And for others of you, you may not have heard about chemical reactions at all. So if you're in the last two categories, I would listen to this section because there will probably be new things. So the setup for chemical reactions is this. A chemical reaction is basically when you take one or more materials, one or more substances, and you convert them into one or more new materials, one or more new substances. What I mean by that, I'll show you a couple of examples. So Ag is the chemical symbol for silver. S is the chemical symbol for sulfur. So you could, there are certain circumstances where you can take pure silver and pure sulfur, and under the right conditions, you can mix these two things together, and they actually end up becoming attached to each other. You end up attaching two silver atoms to one sulfur atom, and you make this thing over here, which is called silver sulfide. Again, you don't need to know the name of this. I'm just sort of giving you an example of a chemical reaction. You start with two things over here that are separate, you do some magic, and then you end up getting them attached to each other. Another example, this is called hydrogen gas. It's made of, each molecule is made of two hydrogen atoms. This is called oxygen gas. Each molecule is made of two oxygen atoms. And they can float around freely, independently of each other, the hydrogen gas and the oxygen gas. They can mix, but they won't do anything with each other unless you put them under a special set of conditions. If you put these molecules under a special set of conditions, you can actually convert them into water. And this is just another example of a chemical reaction. You take one or more substances and you convert them into something else. So those are two types of chemical reactions. The question is, how do you, if you performed a chemical reaction, how do you actually communicate exactly what happened in your chemical reaction? This is one way of doing this, is sort of listing the stuff that you started with and listing the stuff that you ended with. It turns out that these types of listings aren't terribly precise, and we'll talk about why they're not precise in the next bunch of slides, but there are more precise ways of describing what actually happened when you converted something into something else. The way that you do it, the convention that chemists have decided on, is called a chemical equation. So the chemical equation basically tells people this is exactly what happened in my reaction in a way that's much more precise than what I was showing you up here. So what's a chemical equation? Chemical equation basically combines the formulas for the substances that you used and the substances that you produced. What do I mean by that? Basically, what you do is you list the formulas of the substances that you used on the left side of the equation. And if there's more than one substance that you used, you separate the formulas by a plus sign. So here's one of the substances that we used, and here's another one. Both of these molecules were used, and so we're going to separate them by a plus sign. Then on the right side of the equation, you list all of the things that were actually produced. You list the formula for all of the things that were produced. And if there's more than one thing that was produced, in this case there was only one, but if there was more than one, you would separate the formulas by a plus sign as well. So here, this doesn't look much different than what I showed you on the previous slide, and it isn't. But here are the formulas for the materials that you started with, the formulas for the materials that you ended with, and instead of an equal sign in between them, as you would see in a mathematical equation, you separate them by an arrow. So here's the stuff I started with, and somehow it was turned into the stuff that I ended up with, and there's the arrow. First thing I want you to know is that the materials that you start with are formally called reactants. If it helps, these are the materials that react with each other. But the formal name for these substances is reactants. The materials that you ended up with are formally called the products because they are the materials that were produced. So that's where that name comes from. Then the thing is, again, this isn't much different than what I showed you on the previous slide. However, these equations can contain other pieces of information that give you more detail about how the reaction took place. As an example, sometimes you will see parentheses G to the right of a formula. And I'm showing you parentheses G in front of both of the reactant molecules here. Parentheses G means that these materials were gases when they reacted with each other. In other words, this is a little bit of additional information that wasn't on the previous slide. When you see this, the chemist is basically saying, look, the H2 molecules, they were a gas when they reacted. The O2 molecules were also a gas when they reacted with the H2 molecules. That's one type of information that you can see. Sometimes you will see a triangle written over the arrow. The triangle, I have many students often say that this means change. In math, it basically means change. In chemistry, it means something more specific. It means that heat was used to make this reaction take place. So now you have substantially more information about this chemical reaction than you did on the previous slide. Now what you can basically read this and say, look, I started with H2 and it was a gas. I mixed it with O2, which was also a gas, and I had to heat them up before they were converted into water. So that's what the triangle means. So now you can see that this equation now has a fair amount of additional information that wasn't on the information that I showed you on the previous slide. There's more information that can be shown, but at least initially you can see more information than just listing the stuff that you started with and the stuff that you ended up with. As I mentioned in the previous slide, there are other pieces of information that you might find in a chemical equation, and I'll show you some of those pieces here. As an example, here's a different chemical equation describing a reaction that we haven't talked about yet. This is carbon plus oxygen gas, that's what the G means. If you heat them up under the right conditions, they will make carbon dioxide in gas form. That's what the G means over here. However, you can see this type of information as well. If you see parentheses S, the S stands for solid, and what that means is that you used solid carbon, mixed it with oxygen gas, heated them up, and you produced carbon dioxide gas. So again, another piece of information that you might see in a chemical reaction. Here's a different reaction, and again, don't get too caught up in the details, but this is solid aluminum, that's what the parentheses S means, plus something called H2SO4, which is sulfuric acid, makes this stuff. Again, you don't need to know the names, aluminum sulfate, and it will also make hydrogen gas, H2 with a parentheses G. I want you to focus on these two molecules here, the sulfuric acid and the aluminum sulfate. You might see parentheses AQ. Parentheses AQ, the AQ stands for aqueous. If you know Latin or Spanish or some Romance language, you'll know that aqueous basically means water. It does not mean that these materials are by themselves liquid. What it means is that this stuff is normally not a liquid, but it was dissolved in water when the reaction took place. So what this reaction is saying to you, and you'll see the distinction in a minute by why I'm making such a big deal about what aqueous really means. What this reaction is telling you is that you took solid aluminum, you took sulfuric acid that was dissolved in water, and it produced this stuff over here, which was also dissolved in water, and it made hydrogen gas. So why am I making such a big deal about what AQ means specifically? It's basically related to the next type of equation. Here, we've already seen this equation, but it contains one additional piece of information. Hydrogen gas plus oxygen gas, if you heat it up, I forgot to put the little triangle here, will make H2O, and now you see parentheses L. The L stands for liquid. What this is basically saying is you'll make liquid water. And so there's a difference between something that's a liquid all by itself and something that actually is not normally a liquid but actually needs to be dissolved in water. And so that's what the AQ means. L means the material is a liquid all by itself. AQ means that the material was dissolved in water. It could be dissolved in something else, but in this case, the AQ is saying specifically that it was dissolved in water. So a couple of punchlines. The chemical equations can tell you what substances were used up. Those are called the reactants. what substances were produced, those are called products, what the physical state of all of the substances were during the reaction. Were they solids? Then you'll see parentheses S. Were they dissolved in water? Then you'll see parentheses AQ. Were they a gas? You'll see G. Were they liquid all by themselves? Then you'll see L. Another piece of information that you might see was whether heat was needed to convert the reactants to products. And then you'll see a triangle over the arrow that separates the reactants and the products. So what I'd like you to know, and there is other stuff that I want you to know beyond this, but at least from what I've told you so far, what I'd like you to know is you should be able to read a chemical equation and be able to tell what are the reactants, what are the products, what are the materials that were made, what the physical state of each substance was in the reaction, whether heat was needed to start the reaction, and if I give you all of the relevant pieces of information, you should also be able to write a chemical reaction. So if I told you that you used H2 gas and O2 gas, and you heated them up and you produced liquid water, you should be able to write the type of reaction that I showed you on the previous slide with the relevant amount of details.